Welcome to the second session on artificial intelligence, an innovative paradigm for soft computing. I do believe that you would have got an opportunity to Google on the innovations of artificial intelligence that we discussed yesterday. To be specific, on IBM Deep Blue, Humanoid Sophia, IBM Project Debater. Were you able to do that? I also hope the previous session would have given you a kind of insight into the birth, growth, and development of artificial intelligence. So I think you must be having a kind of clear idea about why you're taught should we use artificial intelligence for problem solving, on what occasions do we have to use artificial intelligence for problem solving, and what are its advantages, what are its limitations, and what are the aspects that we have to take into consideration when we decide to use artificial intelligence for problem solving. Well, so now this session, we are going to focus on three different algorithms under the banner of machine learning algorithms. So now let us get into the basics of machine learning first before we start learning about those algorithms in detail. So as you know, this session is titled as Machine Learning Algorithms Part 1. So we are moving further. So this is day 2 session, Machine Learning Algorithms Part 1. So the agenda of this session would be, we will be discussing about an overview of artificial intelligence, specifically the machine learning, then applications of machine learning, types of machine learning, then as I told you, few machine learning algorithms, then we will end with the question answer session. So yesterday we discussed about quite a few definitions for artificial intelligence. Now it is time to discuss on few definitions of machine learning. So I have taken two different definitions that will help us to understand what is meant by machine learning. So the first definition goes like this. Machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. So now we must be able to draw the differences between the definition of artificial intelligence and machine learning. So machine learning is a kind of, it deals with the specific ability of artificial intelligence in terms of the terms as it is put without being explicitly programmed. So now let us try to compare between this artificial intelligence and machine learning. So artificial intelligence is a discipline that aims to make the machine's devices to mimic the behavior, attitude, and cognitive skills of human being. But here we try to differ a little, although the underlying principle is the same. And here we try to be very specific about machine learning, where we call this machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. So here we emphasize on the ability of a computer to learn by itself during the course of the experience it gains by doing a particular task, that is doing the process of problem solving. So why do we call this as without being explicitly programmed? I told you yesterday, any kind of artificial intelligence involves training, and the training gives good amount of experience to the machine. So that experience is used for problem solving, as we all do. Fine. So suppose if a child is being taught how to add two numbers, and the teacher doesn't train a child on solving all possible types of additions. No. What does the teacher do when when a child goes to the kindergarten? The teacher, when he or she wants to teach about addition, they just teach the child the basic principles of addition, right? So that knowledge being acquired by the child must be extrapolated for any kind of addition, may it be 2-digit addition or 3-digit addition or any number of digits of addition. So like that, this is the ideal intelligence of human being. So when we are taught with certain aspects about problem solving, may it be addition, subtraction, multiplication, division, or reasoning or logical thinking, whatever it is. So we gather some experience out of doing certain things, and that knowledge, that experience is being used to extrapolate a problem, similar problem, to be given for solving. This is what happens in the process of machine learning. So when a computer or when a computer program is written for solving a certain problem, because this machine learning algorithm is going to gather a lot of knowledge by the process of problem solving, it is able to handle the cases, different cases of new cases of problem, right? Even though such cases were not thought of at the time of writing the program. Right? So if you have any further doubt, probably we can clarify during the question answer session. So then we will go to the second one. This one may be like a little fussy when you read it for the first time, but however, we will try to defussify as I finish reading the definition. So a computer program is said to learn from experience E, from some task T and some performance measure P, if it's P on T, that is performance on doing some task, improves with experience E. Hope you are able to get this definition. So let me give a very simple example to clarify on this definition. Let me assume like I'm going to learn how to play piano. So I just learn the basics, I learn the principles, then I get trained on playing piano. So I get some experience about playing the piano. My experience should help me to improve my performance from time to time, right? So I must be able to show a good amount of progress on my performance over the period of time as time progresses. So the kind of task that I do is playing piano, right? The kind of experience that I get is my knowledge on playing piano. So the expertise that I show is called as performance. So now I learn to do a certain task. Out of my training, I gain experience. The experience must directly attribute for improvement in performance. So we will come back to the definition all over again. So a computer program, we mean the machine learning algorithms, is said to learn from experience that we get from doing certain tasks, say T, and out of which we get, we may be able to measure the performance that we call as P. And the condition is that any machine learning algorithm must be able to improve on its performance on doing certain tasks T due to the experience it has gathered over the period of time. So as we look into these definitions, that will make us understand what is the ultimate objective of machine learning, and why do we have to consider this machine learning as the most important aspect in problem solving, especially on this innovative computing. So as we look into the definitions of this, the year in which these definitions were coined, the first one was in the year 1959. So now we are in 2020. So these kind of definitions are contextually so relevant because the ideas which were conceived on artificial intelligence, machine learning were so perfect. So then this was the one which was defined in the year 1997. Well, so I told you in the last session, artificial intelligence is the superset and machine learning is the subset. Deep learning is also a subset of artificial intelligence, and deep learning in turn is a subset of machine learning. So I hope you will be able to recollect the pictorial representation that we were discussing with respect to artificial intelligence. Artificial intelligence being the superset and its subset is machine learning, and machine learning has its own subset, deep learning. Hence, deep learning and machine learning in turn will become obviously the subset of artificial intelligence. So now let's proceed further. So now we are done with the definitions of machine learning. Now it is the time to understand further why machine learning is superior over the traditional computing. So the most important aspect is it doesn't require any human intervention. Once the model is deployed, of course, after we develop, we test, and we standardize, we should go for deployment. Once the machine learning model is deployed, probably it doesn't involve any human intervention. So it totally becomes automated. Then, because of its wider applications, it's broadly used in industrial and manufacturing control-based applications. Then, as I mentioned in the previous session, we can apply this machine learning model for many disciplines and for interdisciplinary problems without any exception. So this mass spectrography analysis, mass spectrometer analysis, then drug designing, we discussed about personalized drug design. Then astronomical discovery. These are the examples where science can turn its attention towards machine learning for precise and optimized solutions. So there are certain areas where the human expertise is proved to be a black box. For instance, when we want to talk about the face recognition or recognizing one's handwriting or even speech recognition, we have the limitation to identify a particular face or a handwriting, which can as well be done in a pretty good manner by machine learning algorithms. Why? Suppose if I'm asked to recognize a person who was my classmate probably some 20, 30 years back. So my memory doesn't work well, and I have to scratch my memory wondering who the person is because I'm not able to recognize the person's face. So in such cases, but interestingly, the machine learning models don't get stuck. And based upon the experience they have got, and they will be able to proceed perfectly well, and the face recognition becomes possible as well as feasible. So likewise, recognizing handwriting or recognizing voice of a person or converting from one language to another language. So without much limitation, we are able to apply this machine learning where the human intelligence slightly fails. And then driving a car, we hear much about the self-driving cars nowadays than flying a machine. So in these kind of applications, this machine learning is playing a very significant and amazing role. Then we have to look into this aspect of rapidly changing phenomena. So probably a decade back, there was not much awareness about this debit card, credit card, and whom should be given credit card, and why, whether there is any security for a person if he is given with credit card. So for that purpose, any bank must be able to analyze the credentials of a customer so that he gets qualified to receive a credit card. So credit scoring should be done. And then when a company wants to go for its financial modeling, may it be for cost modeling, human resource modeling, or profit modeling, cost benefit analysis modeling. So in these kind of aspects, or even to talk about risk management modeling. So in these kind of applications, it's proved that machine learning models work very well when compared to human intervention or when it is done by human beings. Interestingly, using machine learning, by using human intelligence. So then as we talk about the diagnosis, it can be like medical diagnosis or diagnosing a problem in an industry. For instance, if we take a nuclear a plant, then we may be able to identify if there is any leakage by having an automated model. And then suppose when we talk about this fraud detection, specifically about this financial fraud detection. So this machine learning models enable us to identify these kind of fraudulence on the fly, online. So when something is happening, immediately it will be able to flag a signal or flag a message saying that something is going wrong. So how this is possible? Suppose if I am going to go for a kind of financial transaction through online, I must be having a kind of a limit. What will be my minimum limit? What will be my maximum limit? So at any point of time, suppose if I try to, as I told you about anomalies. So suppose if I try to exceed this kind of transaction, then probably the machine will be able to understand this transaction is a kind of abnormal transaction. To be very specific, to give an example for this fraud detection online, let me assume my transaction, online banking transaction history shows that my minimum transaction is 500 rupees and the maximum could be, say, probably 50,000. And suppose if there is a sudden transaction either into my account or from my account, which amounts to, say, for instance, 10 lakhs. So then this is taken as a kind of abnormal activity by the machine learning model, which monitors the online transaction, credit as well as debit. So it will be able to take few more parameters to justify whether it is an intentional transaction or unintentional transaction, whether it is a kind of normal transaction or abnormal transaction. So that is the advantage of using this machine learning model. It sits all through and tries to flag a message. It gives an alert when something goes wrong, and these kind of monitoring is not possible with human intelligence. So then when there is a need for customization, when you're going to go for personalization of a particular application. See, as we discussed yesterday, like when we talk about time-dependent advertisement, person-dependent, individual-dependent advertisement, event-dependent advertisement. Say, suppose when we talk about a festival season, or Diwali, or Pongal, or any other kind of festival, on those occasions, we get a lot of advertisements on the respective commodities. So we must be able to provide a lot of decisions to decide about what kind of advertisements are to be popped up on what time, on to which kind of user, and especially, and what are the preferences, interest of a customer, so that their advertisement becomes highly successful. So as we talk about personalized news reading, personalized movies to be suggested, or books to be purchased, on all these occasions, it's proven that machine learning models are much superior than the decisions taken by human intelligence. So let us go to the next slide. And now we are going to talk about machine learning, the concept behind this. So already we have discussed about this in detail in the previous session. We know this artificial intelligence is the superset, and the machine learning is a subset of artificial intelligence. And deep learning in turn is a subset of machine learning. So machine learning and deep learning are subsequently the subset of artificial intelligence. So what does this machine learning do as we go for problem solving? As I mentioned yesterday, when someone wants to master this machine learning, it is very important that one should get familiar with statistical, probabilistic, and optimization techniques. So why do we have to get the basics of statistical, probabilistic, and optimization techniques? The valid reason behind this is, or the valid answer behind this is, the machine learning models, almost all the models, pivot on statistical, probabilistic, and optimization techniques, their theories and principles. So to appreciate the functionalities of machine learning models, to appreciate the scope and power of machine learning models, it is very important that the user must be able to get or grasp the statistical, probabilistic, and optimization techniques basics. So further, the algorithms that can learn from observational data can make predictions based on it. So now we are going to talk about, especially with reference to supervised model, we are going to give both input and output, or as we talk about unsupervised, we are going to give only the input. On all these occasions, the machine learning models will try to understand the pattern that is hidden in the given data, and accordingly, that kind of pattern which has been taken out of the given data will be used for understanding the problem, and then for solving the problem and to give the best results. So the algorithms can learn from the observational data and can make predictions based on that. So what do we understand? We were discussing about the process of problem solving. We have to collect data, and the data to be collected should be perfect in every sense. That we'll discuss a little later. So here, algorithms that can learn from observational data and can make predictions based on remember the kind of pattern which are exhibited by, which are conceived by the observational data. And any machine learning model cannot learn anything beyond the scope of the observational data that we provide for initial process of learning and getting the experience. So it explicitly used for making decisions based on learned patterns, and then it create an analytical model for future predictions. So what is the general idea? We have the set of data, we call them as observational data. So that data will provide a kind of insight into the patterns which are present in the data. So the model takes the pattern, it understands the scope and then the kind of value the data has, the observational data has. So that pattern will be well taken by the model to give the prediction. So now let us just look into the process of machine learning. So we have to collect data, and then the data will exhibit or that will contain some inherent patterns. So those patterns will be understood by the model. The model will train itself with respect to the pattern that has been identified, and then we go for producing the output. That is, it can be prediction, it can be descriptive analytics, it can be prescriptive analytics. It all depends on the kind of problem that we solve using machine learning. So let us again revisit the flow of the process of machine learning. Data collection, then finding the pattern, then training the model by itself, then producing the output. So the accuracy of classification is highly influenced by the distribution and diversity of data. So this point should be taken well, because as we talk about the observational data, the distribution and diversity of the data plays a very important role on the accuracy and the optimization of solutions that we get. So what do we mean by this distribution and diversity? So let us take the case of the corona, which is highly contextual. Suppose if the health department tries to collect the details about the patients who are down with corona, probably let us assume we are going to develop a model which can do the detection process as well as prediction for future cases of corona. In such cases, when we try to collect the observational data, it's very important to understand we should have data in such a way that that should be a representative of patients of different age group. It is not that I only take old age people, or it is not that I take only the infants or the children or the teenagers. It is not like that. So the data set should be complete in nature. So the distribution should be perfect in the sense that, so it must have representatives from different age groups and different categories of patients, right? Male, female, then infants, then children, teenagers, then middle age, old age, and many such things. Only then the model will be able to get a best pattern out of the data that we give. So this is the process. So this is all about the distribution of data. So what do we mean by the diversity of data? So now we are given to understand, depending upon the locale, depending upon the country, it is being told that the coronavirus is getting mutated. So there is a mutation. So to understand the behavior of this corona with respect to various locations, right? So the kind of behavior of corona may be of one type in Tamil Nadu, it may be of a different category as we move towards Gujarat or any other state. So to have a kind of perfect understanding about a particular problem, specifically with special mention to say corona, so we have to collect data from different states so that the data becomes highly diversified, because it is a representative of different locales. Okay, so hope you understand what is meant by data distribution and what do you mean by diversity of data. So now let us proceed to the next slide that speaks about the applications of machine learning. So we have seen most of the applications in the last session. So most of the applications that we list here are a kind of overlapping of what we discussed yesterday. So, it finds a very major role in healthcare services. It's tremendous. So if you just Google and see what are the applications of artificial intelligence and machine learning in healthcare services, you may find a lot of detailed applications. So then language translation, it helps in language translation to understand the language as well as to translate it, to understand the context of what person speaks, to understand the meaning of what a person speaks, because all those things are well exhibited by the humanoid Sophia as well as IBM Project Debater, because they work on the linguistics. They try to work on what it speaks as well as what we speak to the machine. So then online fraud detection, the typical advantage of machine learning is that we may be able to go for this fraud detection on the fly when the transaction is going on, when the crime really occurs. In few seconds, in few minutes, we will be able to flag a message saying that this kind of fraud has occurred. So it is all about the online fraud detection. Please note, it is not offline fraud detection, it is online fraud detection. So online customer support, and suppose if you want to, get in touch with the humanoids, that is the nuance which are being employed by many companies, you can just call to them and they will be able to give appropriate answers to your queries. So online customer support, we have the evidences. Like we do a lot of online shopping and we do a lot of online transactions. There is a very good customer support available for all these kind of online services. Then email spam and malware filtering. We spoke enough about email spam, and so this machine learning model is ideally suitable for the identification of spam emails and then malware filtering. Then social media services like face recognition, face detection, then similar pins, all those things invite the attention of machine learning for the best solution. So then the next one is virtual personal assistants. All of us do experience the power, the support, and the friendliness of personal assistants, voice assistants, which are there in our smart mobile phones. So these things are possible only with the support of machine learning models. So then prediction while commuting, when we are on the travel, and now we have the experience of tracking the trains, and we just want to know at what time we should be there at the railway station, and then we can just make our plans accordingly. We don't have to just wait as per the scheduled time, and we will get to know at what time the train will arrive. We will be able to track where the train is. So these are the advantages. These are the kind of new innovative services which are being provided with the support of machine learning models. So traffic prediction, suppose if you are driving a car in Bangalore or any other highly congested city, and you may be able to select a better route which is less congested, where there's less traffic, so that you can make your travel smooth and enjoyable instead of getting stuck in the traffic and go mad. So then online transportation network, like how best you can optimize the transportation network, everything needs the services of machine learning. So now let us go to the next slide that speaks about the potentials of machine learning. So, so this slide speaks about what do you mean by the potentials of machine learning. Now we are into the next slide. We are done with the applications of machine learning. So now we are going to discuss about the core potentials of machine learning. So what best can we do with the machine learning? So we can categorize them into three major domains. The first one is detection, second is prediction, and the third one is generation. So this detection we have seen enough, like text identification, speech recognition rather. So text recognition, speech recognition, image interpretation, face recognition, face detection, all this stuff. Then just studying the human behavior. For instance, if you have a surveillance camera which is being monitored online, if there is a kind of abnormal movement with respect to a particular person, if there is a group which behaves abnormally, on such cases, like if we can trigger an appropriate message to the person concerned, so the immediate action can be done instantly, and that may help us in having a control over these kind of abnormal situations. So human behavior, then we can go for identity of a human behavior, like you can have the photograph and the corresponding details with the support of which we can confirm access or usage of certain services. based upon the identity which has been decided by the machine learning. Then abuse and fraud detection, we have spoken enough on that. So the prediction recommendations on individuals. So on the individuals, what do you want to tell, like in terms of if they want to watch a movie, or if you want to go for a book purchase, or if you want to buy a car, or if you want to buy, as a anything that you name on the earth. So if you have a model, then it will give good recommendation. Then we may be able to monitor the behavior and condition of human beings. What are the occasions which make a person stressful? What will make a person to be happy? And all those things can be traced by means of machine learning models. Then collective behavior of data as well as human being can also be monitored by these machine learning models. So the next one is quite interesting to speak about generation. So here we are going to go on generation of synthetic visual arts, synthetic music, synthetic text, as well as synthetic designs associated with, say, textiles, jewelry, and wherever there's a need for design, even designs for buildings, architectural structures, all those stuff. So now, as we talk about this generation, what does it really mean? We all know that. We are very clear that once a set of data is given, the machine learning model will be able to understand the pattern, and accordingly, it will be able to produce the desired output. So when I want to develop a model, an artificial intelligence driven model for music generation, for instance, let me assume I'm a person who is interested in light music, right? So then I can make a model to compose light music on its own. How does this happen? I have to collect the preferences of my music interest. So I just collect songs or musics of my interest, then I just give it to the model. The model will understand how the music is being composed. So how they are being orchestrated together, and how the entire kind of music has been composed of. So by understanding the logic behind all these things, the model will be able to generate music on its own. So the days are not very far off where the kind of music that we are going to hear in the future may be completely composed by machines. So then, as we talk about text, it's possible. So suppose if I want a model to talk like me, I can develop a model, then I can train the model. So if I give a text, it may be able to talk like me. So already we have a lot of videos on how the voice of a former president of the United States, Barack Obama's voice was mimicked, and many other world famed leaders' voices have been mimicked. So you will not be able to make or distinguish between the synthetic voice as well as original voice. So that is the power and potential of machine learning, which is quite scary as well, as we look into the gray sides of these kind of technology. Then any kind of design is possible. We can make a model which can go for designing different kinds of new innovative designs for textile industry, or wherever the design is the major concern. So we stop at this point.